Can you make colours disappear? Do we need to think about light every day? Let's find out. Welcome to Science at 6. My name is Andrew and I'm this week's presenter in the centre. I hope you've all had a great week and you enjoyed our plant-based activities. Don't worry if you missed any, you can find them all and more on our CSC online. And keep your eyes open for new experiments and games this week through our social media and in our magazine. And please do send us your results and your questions to openupscience@cambridgesciencecentre.org. Our challenge last week was a research question. Why do we sometimes call forests the lungs of the earth? Most famously, the Amazon rainforest is known as the lungs of the earth, but this actually isn't really true. Let's think about what we mean when we say lungs of the earth. Plants have a process called photosynthesis. They use it to make sugar, which they need for growing and for energy. To do this, they take carbon dioxide out of the air and then they release oxygen. This is the opposite of what our lungs do. We and all animals take in oxygen and give out carbon dioxide. So everything seems like it's in balance. The plants will take carbon dioxide out of the air and then give off oxygen, which the animals will then breathe in, use, and then give off carbon dioxide. But plants also need to take in oxygen. They need that oxygen to get the energy from sugar, just like we do. So a fully grown tree or any kind of plant will actually give out as much oxygen from photosynthesis as it takes in to get energy from the sugar, which means that it's not changing the amount of oxygen in the air. This is the case in the Amazon rainforest, where the trees are mature, they're fully grown. They're not changing the amount of oxygen in the air. But are there forests that change the amount of oxygen? There are. One example are the boreal forests. These forests grow in the far north, almost where it's too cold for any plants to grow at all. In fact, for most of the year, it is too cold. And so, just like the trees that we have here in the UK, they lose their leaves when it's too cold. But when it comes to springtime, they suddenly grow lots and lots of new leaves. And to build all of those leaves, they need lots and lots of sugar. And to make that sugar, they need to do photosynthesis. They take in lots and lots of carbon dioxide, and as a result, they give off lots and lots of oxygen. Most of the sugar they make is used to build the leaves. Some is still used for energy, so the trees do still take some oxygen out of the air, but a lot less than they give out. If we look at this video by NASA, we can see how much carbon dioxide is in the air. The purple and red colours show us where there is lots of carbon dioxide. And as we watch this video go through the year, we can see that around June, which is spring for the boreal forests, lots of that carbon dioxide suddenly disappears. The purple and red colours go away. This is because the boreal forests are growing. They are taking that carbon dioxide out of the air, and in its place, they are releasing oxygen. And it is that oxygen that we animals will breathe for the rest of the year. Now, that was our question, but it's time for some of your work. And Alex, one of my friends here at the centre, is going to be taking a look.
Hello, my name is Alex and I'm going to be answering some of the questions you had around our theme of Plant It. Don't forget to send us in any activities, questions or science-related fun you've been up to openupscience@cambridgesciencecentre.org and you may see your work featured next Monday. So first question is, why do trees lose their leaves in winter? That's from Elizabeth, age 7. So that's a super question. If you didn't know already, a tree's leaves are used to help create food for the trees using sunlight. To do this, the leaves rely on something called chlorophyll, which gives the leaves their green colour. When it starts to get darker and colder outside, the leaves can't create as much food, so they become a bit useless. Instead of wasting energy to keep the leaves, the trees let the leaves die, and we see those beautiful autumn colours appear. Eventually, just a gentle breeze is enough to blow the leaves away, ready for some new ones to grow in the spring. Second question, why are flowers different colours? So that's another interesting question. Plants have bright and pretty coloured flowers like these to attract animals. These animals can help move pollen from one plant to another. This is called pollination. When a plant has been pollinated, it can then start producing seeds to create new plants, meaning more pretty flowers. So take this fuchsia for instance. A hummingbird might visit this flower, take some nectar and get some pollen stuck to its beak. When it goes to the next plant for some nectar, some of the pollen from its beak will move into the new flower, allowing pollination to take place. Different plants work with different animals, so the colour of the flower attracts a specific animal. So it might be bees, beetles, or something else depending on the type of plant. Any questions about this week's topic, please do send them in and we may read them out next Monday.
Thanks, Alex. Now at the beginning, I asked if we could make colours disappear. Well, Mia has an activity to see if we can do just that.
My name's Mia, I'm a science communicator here at the Cambridge Science Centre, and today I'm going to show you how to do a fun science at-home activity. All you're going to need is a piece of card. I've got a circle drawn here on mine, but you can just use the bottom of a mug and draw around it in pencil. And you're going to need some colouring pencils, a pen, some piece of wood, and some blue tack or white tack. So what we're going to be doing is making a rainbow spinning top. So the first thing you need to do is to cut your circle into 7 sections, and that's for the 7 colours of the rainbow. Here's one that I did earlier. In each of those 7 sections you do each colour. So we've got red, orange, yellow, blue, green, indigo and violet. Now, next I'm going to make a hole in the centre of my circle, like this, using my pen. There you go, nice hole. And through that hole I'm going to put my piece of wood, like that. And I'm going to secure it there with my pieces of white tack. Right, there we have it. It really is as simple as that. But what's it got to do with science? Well, when I spin my rainbow spinner, what happens to the colours? And watch closely. So all of the colours disappear and my spinner turns white. What's happening? So all visible light that we see, so that's all colours, combined makes white light. That's quite a weird concept to get your head around, because when you get a load of paint together, you think that all colours mix to make brown, but white's quite special. So all colours of light are mixing to make white. And here we're spinning our spinner so fast that our brain can't separate all the colours of light that are going to it. And so it just sees white light. This is actually the opposite of what's happening in a real rainbow. So with a real rainbow, white light from the sun is coming in and the water is splitting up all the light into its separate colours. Here we are getting all the different colours, spinning them really fast, blending them together to make white light. So give it a go at home, see if you can make colours disappear.
Thanks, Mia. And don't worry if you can't remember all of those steps. Our activity sheet and templates are in the description below. So what was happening there? Well, visible light, the light that we can see, is made up of the 7 colours of the rainbow. If all 7 colours go into our eyes at the same time, our brain mixes those together and tells us that we are seeing white. This only works for light. If you mix 7 colours of paint together, you get a brown colour. With our spinner, what was happening? If we look at only one part of the spinner, say here at the top, as it spins, we see each of the colours of the rainbow in turn: red, orange, yellow, green, blue, indigo, and violet. Because the spinner is moving so quickly, as far as our brain is concerned, we see all of those colours at the same time, and so our colourful disc becomes a white colour. Now we need light every day to make sure that we can see what is around us so we don't bump into things. But now my friend Millie is going to talk to Ashley Rowe, who uses light in his job so that we can all watch amazing things on screen.
Hello Ashley, thank you for joining me. Could you introduce yourself and tell us a little bit about what you do?
Hi, my name is Ashley Rowe. I am a cinematographer. That basically means I'm a photographer, but I work with a moving image. I get to work on feature films and TV drama like Doctor Who. My main job is to light and frame and compose shots for those different productions.
What happens during an average day for you?
We go to the set and have a brief chat with the director and the camera crew, lighting crew, about what we hope to achieve that day. Now, we would have already been to that location before. We would have done what's called technical recce's, where we would have visited the locations with the whole team, and that's the chance for the director to tell us what he has in mind, and then it gives me a chance to tell my team how I would like it to be lit, where I want the lights, where we want the camera crane, where we want the track to be laid. So we get to kind of go over that once more before the actors arrive. Our day is usually about 12 hours. And at the end of that day, though, I'll go home. I will then watch what's called rushes. So I watch what we shot the day before, and sometimes have meetings with the director. So I could work until 10 o'clock in the evening sometimes. So it can be a long day.
Very long day. Okay. So what is it about this job that makes it important to you?
Well, I've always been interested in light. As a young lad, I was interested in still photography, but I was always interested in the quality of light. Daylight is very, 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 very interesting because it changes throughout the day, and it has lots of different qualities, and that I bring into my work, and I try and recreate what natural daylight does.
Fabulous. Does everyone in your team have the same background as you?
No, when I first started working in this industry, I got a job in a film unit for 6 years in Southampton, and then I joined the BBC, and I was working for the BBC film unit for 10 years, staff, and in '93 I went freelance, and that's the way the whole industry went. So nowadays, most people that work in the film and TV industry are self-employed, freelance. So we basically work for ourselves.
Fabulous. And finally, name someone who inspires you and why.
My biggest inspiration came from a film director called Stanley Kubrick. And the reason why was at the age of 15, my dad took me to see my first proper feature film, which was Stanley Kubrick's 2001 Space Odyssey. That film, I was blown away by it, and it was just such an amazing visual film. I sold all my still camera equipment, and I bought myself a Super 8 camera, and I shot little films with my friends at school, and that got me my sort of first job, really. I went for the interview, and I took my photographs, and I took a pile of my little movies I'd shot, and so the guy watched them, and that got me my first job. And from that moment on, all the films that he ever directed really inspired me. He always pushed things to the limit. He made a period drama called Barry Lyndon, which was photographed using lenses from NASA. And these lenses were particularly fast and very sensitive to light. He was able to shoot interior scenes just by candlelight with these fast lenses. So he always pushed the boundaries of filmmaking and tried lots of different ideas. And that's what I try and do. With each of the dramas that I shoot, I try and do something different if I can.
Brilliant. Well, thank you very much, Ashley. That was really interesting.
Okay. Thank you.
Thank you, Ashley, and you too, Millie. Now it's time to introduce our new theme for the week. This week, we're going to be looking at light. Now, the fastest human in the world can run at around 10 meters every second. This is quite slow compared to a rocket, which will blast into space traveling 79,000 meters every second. But even that is incredibly slow compared to light. Light can travel over 299 million meters every second. It's the fastest thing in the universe. So, if you'd like to play with light, grab our first activity from the description box below. And please do send us your results and any questions that you have to openupscience@cambridgesciencecentre.org. Thank you very much for watching, everyone, and we'll see you next week for another episode of Science at 6. Bye.